Hi, and this is section 4.7, graphing linear functions. You can start off on page 262. And the first thing we need to look at is vocabulary again, looking at what is a function, what does it mean, and what does it mean to graph a linear function. Functions we've already learned about. Remember, the function is like a box. You can plug a number in the box will take that number, do something to it, and spit out a result, an input and an output. That's a function. We're going to talk about graphing linear functions today, and the first thing we have to realize when we graph linear functions is that there's going to be what's called function notation. You'll see that highlighted at the top of page 262. We've been using the variables y and x all year, like y equals 3x plus 4. Instead of using y for a variable, we will sometimes use f of x. F of x stands for a function of x. Okay? A function of x is function notation. F of x means the exact same thing as y. F of x means the exact same thing as y. So instead of having y equals 3x plus 4, you could write f of x equals 3x plus 4, and this is called function notation. And remember, when you think of a function, you can think of a box. This is telling you whatever number I plug into the box will take that number, multiply it by 3, and add 4. That's what function notation indicates. So again, this is telling me if I plug x into the box will take x, it will multiply it by 3 and add 4, and then spit out a number. Okay? That's what function notation indicates. So that's the first thing. When you see f of x equals 3x plus 4, you can think about that as y equals 3x plus 4. This is just written in function notation. And I'm showing a picture of that here. And I actually had it drawn up previously. So in other words, if x was 2, if I insert or input 2 into my box, the box will take 2, multiply by 3, and add 4, and f of 2 would equal 10. Now, f of 2, what this means is if I plug 2 into the box took 2 and outputted a 10. That's what f of 2 means. All right? Remember, when you graph, sometimes we make an XY table to graph. We could also think of that table as an f of x table, because f of x and y are the same thing. It's important to know, I'm putting this in red because this is flat out wrong, f of x does not mean f times x. This does not mean a variable f times a variable x. When you see f of x, that stands for a function of x. So this symbol here means we have a function of x. In other words, I can take x, plug it into a box, the box will take x, apply an operation to it, and then output a result. That's what f of x stands for. That's what this symbolism means. And keep on going here. It doesn't matter if we use the symbol f of x, or if we use the g of x, or h of x. All of these things mean function of x, and they all represent y. Just to show you these, if you quickly turn ahead to page 266, if you take a peek right now, and you should actually do this, go to page 266. And what you'll see there in questions 23 to 34, you will see that notation. You will see, my pen is not responding great right now, you will see in 23 to 34 that we have symbols like g of x equals x plus 5 and 23. h of x equals 6 plus x and 24. Q of x equals x minus 1 and 25. Every one of those just mean the same thing as f of x. It stands for a function of x. You will see in the homework, when you look at questions 3 through 11, the directions will say evaluate the function when x is negative 2, 0, 3. So what does that ask us to do? Here's what this is asking. It means take negative 2, and substitute that in for x in your function and solve. So when you look at a question like number 7, where we have m of x equals negative 6.5x, when the directions say to evaluate the function when x is negative 2, 0, and 3, this means to do the following. Take x and replace x with negative 2. So I'm going to take m of negative 2, which means I'm taking negative 2, I'm putting it in the box, I'm taking negative 2 times negative 6.5, and we're outputting 13. So m of negative 2 would equal 13. We also have to put 0 in the box. So we're going to put m of 0 means we put 0 in the box. We're multiplying that by negative 6.5, which outputs 0. So m of 0 would equal 0. We also have to replace or input 3 in the box. So I'm going to put 3 in the box. The box will take 3 and multiply by negative 6.5, and it will output negative 19.5. So m of 3 would equal negative 19.5. M of 3 means we inputted 3 in the box, and the box outputted negative 19.5. So that's what we would have to do on questions like 7 through 11. You will also see questions like on the next page, 266, numbers 14 to 21. Maybe I'll just put a little note for that up here, numbers 14 to 21, where they're going to ask us to find the value of x when the function has the given value. So an example of this would be problem 16. We want to find the value of x in 16 so that h of x equals negative 7x plus 12, and you can see that then they put a colon after that, 9. In other words, I want to find out what is x if h of x is equal to 9. So the given value is 9. I'm sorry, I misspoke. Negative 9 I meant to say. I didn't read carefully enough. So the given value is negative 9 in number 16. After the colon, they gave us negative 9. Here's what that means. That means what can I plug into the box so that when the box takes x, multiplies by negative 7, and adds 12, we get negative 9 for a result? Well, think about what that's asking us to do. Remember, this is x, this is my y value. So in other words, if y equals negative 7x plus 12, I'm being told right now that I want y to be negative 9. So in other words, my equation would be negative 9 equals negative 7x plus 12. I just have to solve that. I can take away 12 from each side, which gives me negative 7x on the right and negative 21 on the left. And then I can divide by negative 7, and I get 3. So if h of x works out to negative 9, that means we had to plug in 3 originally to get that. A common error in this problem would be to just take, I'll circle it in red, would just be to take negative 9, waiting for this to respond, take negative 9 and plug it in here. If you do that, you're going to get negative 51. You're going to take negative 7 times negative 9 plus 12 is 51. That is incorrect. Okay? They didn't tell me x was negative 9. They said the given value of the function was negative 9, which means the correct thing to do, I'll do that in green, the correct thing to do is to take negative 9 and replace h of x, or y, with negative 9 and solve an equation. Okay? In question 13, no, this is not question 13. I'm going to pause this for a second to make sure I got the right question here. this isn't question 13. This just must be a problem I had made up. We want to find the value of x so that the function has the given value. So if I want the function to equal -7, that means I have to plug in -7 for f of x. I want to find out my x value when f of x worked out to 7. So I don't want to plug in -7 for x. I want to plug it in for f of x, which would be y. All I need to do is solve this now. I'm just going to do the way I've been teaching you all year here. If we're adding 9, we can take away 9 first from each side, which means we have a cancellation. We will get 8x on the right and -16 on the left, and of course we can divide by 8, and x would equal -2. So in other words, if I take f of -2, which means if I plug -2 in for x, if I input in -2, the output will be -7. All right, so this next thing, and then I can wrap up the video. The next thing would be on page 263, and you'll see a couple of vocabulary words on 263 near the bottom, parent function and family of functions. A parent function is the most basic function possible in slope-intercept form. And right now, we're going to talk about this family of functions. And maybe I should highlight this here or put a little note here. The family of functions we're talking about right now are the functions that are written in slope-intercept form. And slope-intercept form, remember, that means y equals mx plus b. So I have a family of functions. Any function that would be in this form is part of the family. The parent function is the most basic of this form. So if you think about it, the most basic thing I could do is have 1 for my slope and have 0 for my intercept. F of x equals x would be the most basic function in that family. That's called the parent function. So I kind of think of that as f of x equals 1x plus 0. So if I go and I graph that, if I graph the parent function, it looks like this. My y-intercept, let me write this out one more time. My y-intercept, remember, is 0, so let me highlight that a little bit. My y-intercept is 0. You can see I sketched that. And my slope right now is 1, so you can see that each time I rose 1 and run 1. Rose 1, run 1. Rise 1, run 1. I did that each time. And you can see that there. Now, if I give you another function like you see on page 266, numbers, let me highlight this. We're talking right now about numbers 23 through 34. They're going to ask us to do the following. They're going to ask us to graph the function and compare it to the parent function, f of x equals x. So first of all, I did graph the parent function so we can see it. Now let me graph this function. You'll notice on this function my slope is still 1, just like it was on the parent function, but my y-intercept's different. My y-intercept's 9. So let me graph this. I'm going to go ahead and I will take the y-intercept of 9 and I will plot it right here. And my slope is 1. That means rise 1, run 1, rise 1, run 1, and so on. And you'll see that I've created a second line. Now, they asked me to compare the two, and you'll notice when I compare these two, there's some things that they have in common, and there's some things they have different. First of all, when I compare them, do you notice they both have the same slope, which means they're parallel. Remember earlier in the chapter, if we have the same slope, they're parallel. So when I compare these two, I could say both lines are parallel, or both functions are parallel. But the function d of x equals x plus 9 is shifted up 9 units. Do you notice that all I really did is I took this line and I pushed it up 9 units? Can you see I'll do this in red so you can notice it. Do you see how this line has basically been shifted or translated up 9 units? It's like I took this line, and I could probably show this better with a ruler, so let me get out my ruler. I just took this line and I shifted it up 9 units. And I'll show you that right now using a ruler. That'd probably be the easiest thing to do. So let me take my ruler, and I'm just going to do this. Okay, I took this line, which is here. There's the parent function. Can you see if I just take that edge and move it up, move this up 9 units, there's my new line. So that's how I can compare the parent function. Let me get rid of the ruler. That's how I can compare the parent function, which again was f of x equals x. And I can compare that to the function d of x equals x plus 9. I would say that both of these functions have the same slope. They're parallel, but the function dx equals x plus 9 was shifted 9 units up in comparison to the parent function. Let's do another. Let's go to question 24. Question 24 says we have h of x equals 6 plus x. All right. First of all, the parent function, of course, is f of x equals x. So I graphed the parent function. Remember, y-intercept is 0. I graphed it. Slope is 1. You can see up 1 over 1, up 1 over 1 each time. Now let's graph h of x equals 6 plus x. So I want to graph h of x equals, I'm going to put x plus 6 because the order doesn't matter. Okay, my y-intercept is 6, so I'll put that here. My slope is 1. That means go up 1 over 1. Go up 1 over 1. Go up 1 over 1. Let me get my ruler out, and I'm going to draw a line now. So I'll get my ruler out. Let me draw a line through these points. I'm going to do that right now. And put arrows at the end. And now I want to compare the two. So when I write out a comparison, this is what I would write. I would write f of x and h of x are parallel, because they are. Do you notice the slopes are the same? But h of x is shifted 6 units up in comparison to the parent function. So I just wrote a comparison as they asked me to. All right, I think you can see that there. Let's do another one, 26. Remember, here's my slope-intercept form. This is just a little review. I think we have this down, though. Remember, m is my slope, y is my intercept, and my parent function is f of x equals x. So let me graph that. There is f of x equals x. Remember, intercept 0 right here. Slope 1, up 1 over 1. My second function that I want to compare to the parent function is g of x equals x minus 6. So let's graph that. Remember, first of all, here's my intercept way down here at negative 6. But my slope is still 1, up 1 over 1. So let's compare the two. They both have the same slope. I guess I could have put their parallel. They do have the same slope, but g of x is shifted down 6 units. Can you see that downward shift? We took the parent function and we just basically pushed it 1, 2, 3, 4, 5, 6 units down. I just used red there so you could see if there was nothing wrong. And let's do one more. In number 30, I want to take the function wx equals 5x and compare it to the parent function. So first of all, let's graph the parent function again. And we've done that many times now. Y-intercept 0, and slope, of course, is 1. And so you can see that I applied a y-intercept 0 and a slope of 1, up 1 over 1. There's my parent function. Let's graph now w of x equals 5x. W of x equals 5x. Now remember, when I graph this, remember this is like having w of x equals 5x plus 0. Remember, there's like a plus 0 here. So when I graph this, the y-intercept is still 0. But my slope is 5. That means I'm going up. Let me sketch that so you can see it clearly. So when I sketch this, I'm rising 5 and I'm running 1. I'm rising 5, I'm running 1. Or I guess I could think of it as falling 5 and going left 1. You can see I have 3 points in blue. Let's draw the line through those. Okay, now they want me to compare these two things. They want me to compare the parent function to the function wx equals 5x. So let's compare the two. I'll write a statement for that. This time, do you notice they both have the same y-intercept? They both have a y-intercept of 0. However, w of x, it's steeper. We don't use the term steeper in algebra. We would call that a stretch. W of x is stretched by a magnitude of 5. That means the slope on wx is 5 times greater than the slope of the parent function. Now that should make sense, right? If the slope here is 5 and the slope here is 1, the slope of the parent function is 5 times greater. So we would just write in words, we would just say that the slope of w of x is stretched by a magnitude of 5. That's what we need to do in section 4.7. So again, we have 3 main tasks. I'm going to ask you on page 265 to evaluate a function given values. That would be what I showed you. Let me go back several slides. That would be what I showed you to do here. So this is, I went back one too many slides. I went back way too many slides. Hold on. Here we go. So here's one task we have to do. Evaluate a function when given a given value, like on page 265. Second major task. Find the value of x when the value has the given function. That's the kind of problems we did on page 266, numbers 14 to 21. And then a third major task we need to do in this section would be to graph the parent function and then compare the parent function to a new function and be able to compare that in words. So graph the parent function, graph the actual function, and make a comparison of those two functions in words. We'll stop the video here. If you have any questions, of course, come tomorrow. We will go through anything you have regarding the video and any questions you have.